Hello everyone, I am Vignesh, studying BE Computer Science in Sethu Institute of Technology. Today my seminar topic is liskov substitution principle. The liskov substitution principle, I am going to cover the topics that introduction to liskov substitution principle, the definition of a liskov substitution principle, the liskov substitution principle and the explanation of the liskov substitution principle. Let me see the introduction of the liskov substitution principle. The liskov substitution principle is the third of Robert C. Martin famous solid design principle. The word solid stands for S stands for single responsibility principle, O for open closed principle, L for liskov substitution principle, I for interface segregation principle, D for dependency inversion. And we see the definition of the liskov substitution principle. The liskov substitution principle was introduced by Barbara Liskov in her conference keynote data abstraction in 1987. A few years later, she published a paper with Janita Wing, which they defined the principle as let theta x be a property probable about objects x of type t, then theta y should be true for objects y of type s, where s is a subtype of t. The solid stands for single responsibility principle, O for open closed principle, L for liskov substitution principle, I for interface segregation principle, D for dependency inversion principle. The liskov substitution principle functions that uses pointers to base class must be able to use object of a derived class without knowing it. Thus, the object of the subclasses should behave in the same way as the objects of the superclass. This principle ensures that inheritance is used correctly. If a override method does nothing or just throws an exception, then you are probably violating the LSP. The classic example of the inheritance technique causing problems in the circle ellipse problem. Example, the rectangle square problem, which is a violation of the liskov substitution principle. The liskov substitution principle can be explained in short way that derived class should extend without the replacing of the functionality of the old class. That is, we are seeing the example of a liskov substitution principle. In 2005, the Visual Studio was launched and it was upgraded and launched in the year 2010 with more compatibility. Now let me see the explanation of a liskov substitution principle. This principle says that function that uses references of a parent class must be able to use object of a child class as well without knowing it. It means methods that can use superclass type must be able to work with the object of derived class without any issue. The user of a base class should be used an instance of a derived class without knowing difference. Enforcing the liskov substitution principle. If you decide to apply this principle to your code, the behavior of your class becomes more important than its structure. Unfortunately, there is no easy way to enforce this principle. The compiler only checks the structural rules defined by the Java language, but it cannot enforce a specific behavior. You need to implement your own checks to ensure that your code follows the liskov substitution principle. In the best case, you do this via code reviews and test cases. In your test cases, you can execute a specific part of your application with the objects of all subclass to make sure that none of them causes an error or significantly changes its performance. You can try to do similar checks during a code review, but what's even more important is that you check that you created and executed all the required test cases. Now we see the triggers. Errors could be raised by a subclasses that are not expected raised by the subclasses. Subclasses with more constraints than base classes. Forces. The LSP should be used if there is no reason for the underlying process to know about any more than the base classes, An example would be the strategy pattern where the caller should not require any additional information about the specifics of the strategy. It is accepted or desired that the code using on the base class will be reused elsewhere and may encounter alternate derived classes. The LSP may not be completely appropriate if a subclass needs to strengthen precondition. The base class has a method that accepts any some base class as a parameter, but the child class requires a class inherited from some base class. A subclass needs to weak post condition. The base class has a method that always returns a value in the range 1 to 100, but the child class needs to return a value of 101. A subclass needs to provide an exception condition that was not present in the base class unless the exception object is itself a subclass of a valid exception object raised by the subclasses. Resources: The Design Principle and the Design Patterns How by Robert C. Martin. The Liskov Substitution Principle, a paper by Robert C. Martin. Hansel Minutes podcast 145 on solid principles with Scott Halmanson and Robert C. Martin. A discussion of LSP on the C2 wiki. An alternate view of the LSP. Suggestion that context and usage are more important by Alistair Cockburn. Thank you.